priority 9, and there's no other competition, so I'll run soup. Okay? Comes down and hits something at priority 7. There's 3 of them, so what does it do? It gives a little to D, a little to E, and a little to F, and it just keeps circling them until they're all done. Does everybody understand? Round robin. Everybody gets a little piece of action. Okay? Then 6, there's only 1. 5, there's 2, and so forth. Now we have a couple of problems with this. Okay? If I'm working on 6, priority 6G, and all of a sudden a priority 10 comes up, it's going to stop what it's doing on priority 6, jump up and do what's on priority 10. It interrupts the process and says, you're low priority now, I got to do the other one. Okay? Makes sense. All right? But if you're this little guy down here on priority 2, and here I'm on 6 and a 10 comes in, and then I come back to 6, I go down to 5 and all of a sudden an 8 comes in, I'm working on this round robin here and a 7 comes in, or a 10 or a 9, the little old 2 may never run, right? He's starved, that's starvation, okay? He can't get any time on the processor. So what the system typically does is the longer you're a lower priority, it begins to bump your priority up, so you become competitive with the others. Okay? Now you can change all of this at the primitive level if you want to go in there and muck with it, and I wouldn't suggest it. Okay? This is not easy programming. Okay? It will be for us because we're doing little sequences. Okay? I've worked on several actual parallel processing machines for the government where we've had tons of processors, and it has been a nightmare to try and get all these things to come together. Okay? I mean, you would think if you have, for example, 10 processes, things would run 10 times faster. Well, no. Okay? Because they have to communicate with each other to get the final answer. Let's say I have an array of 10 rows. Okay? And 10 columns, doesn't matter. Let's say I have 10 rows in a 2D array. I give each row to a processor to add up. Well, they can add it up real fast, but if I want the total of the whole array, I still have to get the answer from each one of those 10 and add it up. So it still takes time for all these processes to talk to each other. Okay? Now, it does speed it up something, needless to say. Okay? But it's not a one-for-one speed up or anything like that. Okay? And it's not so much writing the threads themselves, or the processes are called threads, processes, whatever you like to call them, okay? It's how you get them to communicate with each other. That's tough. Okay? There's been a lot of time spent on that. So, right, round robin, high priority first. Everybody gets a little time slice. Now, when you read this section of the chapter, there's a bunch of bold, big red words. I know those big red words. A lot of good definition stuff in there. Okay? Just so you know. Okay. So let's go see. Okay, so the first one he's got up here is the first example in the chapter. He's called it print task. Now, let's just run through it a little bit. Now, there's a couple of ways to make threads. He feels the best is to implement the runnable interface. Okay. We'll see another sample. Anyway, implement the runnable interface. Okay. The runnable interface has one method, run. Okay. So you have to provide the run method that tells the process what to do. Okay. But let's look at the classes here. Okay, he's going to randomly generate a sleep time. I don't expect you to know how to randomly generate a number or anything. It's pretty easy. But anyway, he comes in, he generates a sleep time up to 5 seconds. Okay. This is all in the book, and it's on the blackboard because I gave you the code. And then in his run method, you have to have a try-catch. Okay? You've always got to catch for interrupted exception, because if you try to talk to a process that for some reason is asleep or dead or whatever, that's an interruption, okay? And that's going to be a problem, because if it's dead or asleep, you can't talk to it, okay? All right. So anyway, he just prints out the name of the task and the sleep time. And then there's a thread class, and it's got some methods in it. One of them is put yourself to sleep, which is the sleep method. So he says thread.sleep, the sleep time that was generated. Okay? And then all he does is say when he woke up. That's all he does in this thread. He generates a random number up to 5 seconds. He puts himself to sleep for that time, and he wakes up and says, I'm awake. That's all this thread does. Okay? The question is, it's over here somewhere, I hope. What was that? Yeah, there it is. Okay, just make sure I have the code here so we can run it as well. Okay. All right. Then, okay, that's just the process that you want to establish. That doesn't make it anything. It's not even a program because it doesn't have a main in there, right? And in fact, threads or processes are not programs. They're separate executable segments, but they're not programs because they're not mains. Okay? What you have to do is you have to have a class with a main to get all that stuff going. So let's go look at how to do that. All right. That's not the one. Where's this other one? This is the one he's got in the book. This is one set older slides than this book is. Okay? So this is the one he's got in the book. Okay? And what we're going to use is the executor service to handle all our threads. Okay? It was new in about version 5, I think. Okay? Because up until then you had to use the old version of stuff. Okay? So we're going to use executor service and executors. Now, executor service just establishes a pool of threads, and it assigns them as it needs to and keeps control of everything. You don't have to worry about who assigns what to whom or how or when. Okay? You don't have to worry about running out of threads. This will handle it for you. Okay? And it basically tries to run your operating system more efficiently when you're doing threads. Of course, it's only efficient as the guy who wrote the executor service. Okay? Let's remember that as well. So, we're going to import all that nifty stuff. Okay? We're going to create